Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list published on September 16, 2025, just yesterday. The standout claim is that an open model, trained with synthetic uncertainty-rich data and scalable reinforcement learning, matches proprietary agents on tough web research tasks. The paper is titled WebSailor V2, Bridging the Chasm to Proprietary Agents via Synthetic Data and Scalable Reinforcement Learning. And as we will see later, the implications for model training are quite significant. In short, the work pairs a dense synthetic data generator with a dual environment reinforcement learning pipeline to teach agents to systematically reduce uncertainty while browsing and reasoning. Also, the authors shared a GitHub repo. You will find the Tongyi Deep Research Agent code with agent and web agent modules, inference and evaluation scripts, setup instructions, model download links, benchmarks, and a scalable synthetic data and RL pipeline. It includes example datasets, run scripts, requirements, and notes on React and heavy research modes. Alright, Figure 1 highlights the headline result. The proposed agent leads both browse, comp, en, and x bench deep search, which signals competitive deep research ability. The bars compare end-to-end agents on standardized web research tests, so higher values mean better multi-step browsing and reasoning. The left chart shows a clear win on browse, comp, en with a margin over strong baselines. The right chart reports the best score on X bench deep search, reinforcing that the gains are consistent across settings. So Figure 2 shows the closed loop that keeps the agent learning continuously, because data, policy, and rewards flow end-to-end. The top pipeline links automatic synthetic data, rollout collection, trajectories, and a reward service. The lower left box highlights the two training arenas, a simulated environment and a real environment. The lower right box lists the orchestrated tools, including Search, Google Scholar, Visit, and a Python interpreter, which standardize actions and make training stable. Table 1 makes the core claim concrete. The 30 billion WebSailor V2 reaches top open source scores across all listed benchmarks, and it challenges several proprietary agents. The table reports pass at 1, which means the agent succeeds if its first full attempt solves the task. The reinforcement learning version beats the supervised model by a clear margin, so training beyond the cold start matters. The strongest gains appear on browse, comp, zh, and x bench deep search, which signals robust multi-step browsing and synthesis. Alright, Figure 4 shows that reinforcement learning steadily improves both accuracy and reward as training progresses. The left and middle panels track pass at 1 on browse, comp, en, and browse, comp, zh, which means the first attempt succeeds more often as steps increase. The right panel plots reward with an exponentially smoothed curve, and it trends upward despite noise, so the policy keeps getting better. These trajectories indicate effective learning within the training distribution. Wrapping up, two takeaways stand out. Dense, uncertainty-rich synthetic data, plus a stable dual environment reinforcement learning loop, can teach mid-sized agents to systematically reduce confusion on the web. And strong supervised cold start makes sparse reward reinforcement learning viable, with reinforcement learning delivering the final lift. The broader implication is that data and environment quality, not algorithm tricks, drive frontier agent gains. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.